Hi everyone, welcome once again to MOG Economics YouTube channel. Um, Now, in today's class, we're going to be, let me put it this way: today's class will be a continuation of what we started last week, which is Taylor series. So, from our last class, we started with the concept of Taylor series, and so now today we are going to be starting with these two key questions here, just to deepen our understanding of the concept of Taylor series. So now the question says find the first four term of this function near this value, near 1, and this centered at. Now, for Taylor series, you are going to be given a specific value around which you are going to expand the given function. In this case, these are the functions. Unlike Macroeconomics where the value stays at 0. In this case, we have 1 to be the value. So we are expanding this function around this. So now, you recall from the last class, we came up with a formula which is the Maclaurin formula, the Taylor formula. So now at this point we have to recall the formula. So which is so okay, in this case, because here let's use this value. So it won't bring any form of confusion. Let's just have this, and the first order. So here you open another bracket here just to show deviation. So here let us have this. So this is a measure of the deviation. In the last class, we have something like this. So this, bringing this to the other side here, we have this minus this. So this is just a measure of deviation. Now the second order will be this. So increasing this, then now we have this. But in this case, this will be raised to the power of 2, and then the third order. So this will be raised to the power of 3. Alright, so we can start with each of the individual uh, differentiation. So for the first order differentiation, have this. So this here is for this, in this case we have two entities that are joined together by a product. So here we are applying the product rule of differentiation. So here we can represent this with u and this v. So let's just have our solution on one side. Let's say here our u is this and our v is this. Now, so by differentiating this we have 1, and by differentiating this, the v, the x, we have, so in this case, here we are applying the power function rule to differentiate this. Now this here, you differentiate this power, that term which is 1, in this case is x, so when you differentiate you have, and then you multiply it by this original function which stays the same. So we still have this e raised to the power of x, and the result is still e raised to the power of x when you multiply it by 1. So now applying the formula for follow through, we have okay, u dv dx plus v du dx. In that case, we have our u from here is this, so x minus 1, and then our dv dx is this e to the power of x, then plus our v from here is e raised to the power of x, and our du dx is 1. So here simply we have um, this x minus 1 plus this. So this can be reduced This can be further simplified, and you can have something like this. Factorizing e to the power of x out, so we have this plus 1. Then this cancels this out, so this is 0. Minus 1 plus 1 is 0. Then we are left with x raised to the power of x. The result is x e raised to the power of x. So now let's take the second order differentiation. And so that's the second one, to get this, we differentiate this again. And again we are applying the product rule. So here we have two entities again, being separated by a product. So now let's drop this off, and so we can use this space for calculation. Alright, so here we are representing the first term here as u, and then the second one here as v. So here, differentiating this, we have 1, then the v, the x is, now from the previous calculation, this stays the same. So we don't have to repeat it again. So e raised to the power of x is still our answer. And then applying the formula again, this multiplies this as plus this multiplies this. So we have x e raised to the power of x plus this. So this can be simplified, and then the result is this x plus 1. So here our second order notation is x raised to the power of e raised to the power of x, then into the bracket of x plus 1. Now the third order differentiation, which is the final one here, okay, is, so now at this point again we are differentiating this function, this second order, the result of our second order differentiation, we are differentiating again to get the third order differentiation. So now again we do the same thing. Now applying the product rule on this. So we have here representing the first entity here with u, and the second here representing with v. So now again the u dx is e raised to the power of x. I believe now we know why it is so. And then here the v dx is, differentiating this, we have just 1 as the answer. So now applying the formula again, u multiplied by this, we have this
No.
U dv, sorry, as u dv dx, right, plus v du dx, x plus 1, and e raised to the power of x. So here we have e raised to the power of x plus 1, e raised to the power of x. So again we can simplify this further, and then so we have something like this: e, open a bracket, then 1 plus this, x plus 1. So we have e raised to the power of x, we have 1 plus 1, that is 2. So let's bring this forward just to make it look nicer, or something like that. So we have e raised to the power of x, and open bracket, into bracket, x plus 2. Alright, so that's the result. We have e raised to the power of x plus 2. Alright, so now at this point we have to apply our formula. So by applying our formula, we have, okay, let's rub this off. So we going to have to substitute the value, since we are expanding this function around this particular value near x equals 1. So for the first function, which is the original function here, we can have the result of this by just simply substituting this value here into this particular function. So if we do that, let's start with that. Okay, let's say so that let's have something this way. So for the first one, which is this gx is this. So substituting the one here. So this whole expression is 0. Now for the first order derivative, the result here, we have this. So inserting 1 here. So this is e. Here, this becomes, so substituting 1 here again, we have e, then we have 1 plus 1, which is 2e. Then for the third one here, we have again substituting the value of 1 into this. Here we have 3. So here we have e. So here we have 3e. So now we can simply substitute our values. So for this first one is 0. So automatically we don't have to insert anything there. Since it's 0, just leave it out of the formula. Then for this is the result. So we just simply substitute here. So we have e, this is 1, and then this. Now note this here, this stands for this, because this is the value we are expanding. This stands for the value we are expanding around or near. So in this case we are expanding near 1. So this is the value, this is the value we wish to expand our function around, but this is the one we eventually expand our function around. Now this is just a measure of the deviation, the dispersion that we wish to expand our function around this, but this is what we eventually expand our function around. So meaning this is a measure of that deviation. So here this is what we're written as a 1. So here we have this. Okay, for the sake of, let's say, clarity, let's just put the 1, so it won't cause any form of confusion. Let's just still leave the 1. Then for this is the result here, 2e. So 2e, and here we have 2. Again, here x minus 1, substituting the value here, we have this. And for the third one here, this is the result, 3e. Now, the denominator here, the factorial of 3 is expressed as this. And then here we have x minus, again substituting the value here, then we have this. So at this point, let's cancel out what has to be cancelled out. In this case, we have this cancelling this out, and here this cancels this out. So we are left with n plus e x minus 1 raised to the power of 2, and plus this, which is e this raised to the power 3. So that's it. Or an alternative way to write this would be, so we can, instead of leaving this behind at the back, we can bring it forward, and then we have something like this. So it's just a way of rearranging it. Still the same thing. Just here, then for this, we have, and then this is the answer. So when we differentiate ln x, that's the first order differentiation of ln x is 1 over x, and this is the result. Now the second order differentiation of this So we are differentiating this now second time. So that this is another way to represent this is x raised to the power of minus 1, and then differentiating this will be minus x raised to the power of minus 2, which is the same thing as 1 over minus 1 over x squared. So then the third order differentiation, the third derivative, yeah, all right. So we are going to differentiate this again. Now, this can be expressed this way. So we have minus 2 x raised to the power minus 3. So we have 2 x raised to the power minus 3, which is right. So 2 x raised to the power minus 3 is 2, then x raised to the power 3. Okay, that's 2 1 over x raised to the power 3. So that is 2 over x raised to the power 3. Alright, so this is it. So now we apply our formula again. So we have so in this case, the letter we are using here, so we just simply replace, instead of using x this time, we are using a. Since we are expanding around, we are giving a variable here, a, which is a, to expand around. So here we are using a instead of x. So here we have let's just say a. Then second order, this will be raised to the power of 2. Then third, alright, and this will be raised to the power of 3. So now this point, right, so here we have to substitute the 1 into the derivatives. So here we have, now for this first one, let's substitute 1 here. We have 1 over 1, which is 1. For the second derivative, we have minus 1 over 1 raised to the power of 2, which is minus 1. And then for the third one, we have 2 over 1 raised to the power 3, which is 2. Right? So now we have, now for the first original function, we mix that out. Let's just have this, the original function here as lane 1. Lane 1 is 0. So, alright, so here we can start imputing our values. So here, this is 0, so automatically this drops out. So we don't have to write that. And for this one, the first one is okay, that's 1 from there, x minus 1, then plus this, the second order derivative, that's minus 1, and this is 2 times 1. And here we have x minus 1 plus this. Yeah, so now the third one, this is the result. That's 2 over, this can be expressed, this 3 factorial can be expressed as 3 times 2 times 1. Then x minus 1 or raised to the power of 3. Alright, so here there was supposed to be a square from the formula. Sorry, there's a mistake here. So now here we have x minus 1. Then here this changes to minus. Then we have x minus 1 raised to the power of 2, and this over 2, and plus. So this cancels this. Then we have x minus 1 raised to the power of 3 over 3. Right? And okay, we can further express this as x minus 1 minus plus 1 over 3 x minus 1 cube. And that's the answer. Alright, so at this point, I don't know if you have any question. If you do, you can drop your questions in the comment section below. And also, this will be the assignment for this class. The question says, find the first 3 terms in the Taylor series for. First one is name into the bracket of x plus 1 raised to the power of 2. Second one is x, the natural log raised to the power of minus x. Alright, see you in the next class.